Hello friends, welcome to my channel. Today we are going to discuss about some principles of software testing. So basically in our software testing we have to follow the 7 principles. So by this principle we can follow our testing process. So that is called as 7 principles of software testing. So what are those 7 principles? The 7 principles are: first, testing shows presence of defects. Number 2, exhaustive testing is impossible. Number 3, early testing. Number 4, defect clustering. Number 5, pesticide paradox. Number 6, testing is context dependent. And number 7, absence of error fallacy. So these are the 7 principles that we have to follow in our software testing process. So you have to remember these 7 names. Testing shows presence of defects. Exhaustive testing is impossible. Early testing, defect clustering, pesticide paradox, testing is context dependent, and absence of error fallacy. So we have to remember that 7 names. So whenever we will do any testing, whenever we will perform any testing, so we have to make sure that process. These are the 7 principles. So what are all those? So in detail, I will let you know. I will discuss with you. First point is that testing shows presence of defects. What does it mean? I'm giving you one real life example. Then you can understand that what does it mean. Testing shows presence of defects. That means suppose you are testing a TV remote. Suppose you are testing a TV remote and you can see that all buttons are working perfectly fine. That means you cannot tell that the whole TV remote is perfect or working correct. Suppose you are testing a TV remote and you notice that all the buttons are working perfectly fine. That means we cannot say that the whole TV remote is working perfectly fine. Maybe some hidden issue is there. Maybe there is some hidden issue. Okay. So that is called as testing shows presence of defects. We are testing all the application. That means we cannot say that the application is bug free. Maybe there is some hidden bugs or defects are there and we have ignored that, or we didn't notice that. Okay, that is called as testing shows presence of defects. Suppose we can find bugs by testing, but we cannot say there are no bugs at all. Maybe there is some hidden bugs are there and we have missed that. Okay, that is called as testing shows presence of defects. Point number 2, exhaustive testing is impossible. Means suppose you are testing a calculator. I am giving you one real life example so you can match with that point. Suppose you are testing a calculator. So it would take forever to try every number and operation. Okay, so you will test only the main important keypad, like you are doing addition, you are doing subtraction, you are doing multiplication, you are doing division. So you are just performing this. So you are not trying another things. You are not trying any another operation. So only the important ones you are testing. So that means exhaustive testing is impossible. Means you cannot test everything, because in a calculator there are so many combinations are there. Suppose let's say you go for a shop, you go for a mobile shop and you want to buy a mobile. So what you will test? What will be your testing? First, obviously, what we will do, we will switch on that mobile. Then suddenly we click on that camera icon and we capture one photo. Okay, so that is the first thing. Then immediately we open the YouTube and we will see that the video is opening perfectly fine or not, and the sound is perfectly fine or not. And again immediately you will call some another friends and you are checking that calling features is working perfectly or not. Okay, That means in a mobile there are lots of combinations are there, but we don't know all of them. We cannot test everything. Whenever we are buying a mobile, we cannot test everything. So the important ones we will check. That is called as exhaustive testing is impossible. Means lots of testing, too many combinations that we cannot test. So we cannot test everything. Too many combinations maybe exist. That is called as exhaustive testing is impossible. Now, point number 3, early testing. What do you mean by early testing? Early testing means, suppose, let's say one example, suppose you are building a house. So it's better to check the foundation early rather than fixing a crack in the wall later. Right? You are building a house, so always it would be always it would be better to check the foundation early rather than fixing a crack in the wall later. So always we have to do the early testing. So start testing as soon as possible. Why? Because if you start testing as soon as possible, then you have a multiple scope to find the bug early and to find the bug in lots of time. There will be lots of time and you will get maximum time to test your application. So it will be better to start testing as soon as possible. That is your third principle. You have to follow that in your testing process. Point number 4, defect clustering. Defect clustering means money. So we can say defect clustering means, suppose let's say I am giving an example. Suppose in a school app, most issues are found in the online classes section. Suppose we have a school application, school attendance application or school application. So maximum issues are found in the online class section because it is used the most and has many features. So obviously where lots of features are present, so their testing scope is more and we can found lots of bug on that particular feature or particular area. Just like suppose you are using a school app and we found most of the issues in the online classes section because maximum time we use the online classes section because it has many features. So that's why that is called as defect clustering. Means most bugs are found in a few key areas. In a few key areas, we can found lots of bugs. So there are two scenarios. Suppose just for example, so suppose you are a tester, I am a tester. Okay. Now, let's say I am testing all the application, but you know that where in particular application, which is the key area, you know that. And you immediately jump to that feature and you are testing that particular feature and you will get lots of bugs. Suppose in application there are 10 features, I am testing 10 features simultaneously and you are testing only one feature and at the end you found 20 issues, I found 10 issues. So your productivity is high because you found lots of issues comparing with me. That is called as defect clustering. So most bugs are found in a few key areas. So we have to make sure that whenever we are following the testing process, you have to make sure that in that particular application, what is the key area, what is the key feature on that application, and you have to check that feature first, so you will get more bug. Okay, that is called as defect clustering. We have to cluster. Now, number 5 principle. What it says? Pesticide paradox. Pesticide paradox. It means, suppose, let's say you are a farmer. Okay, suppose you are a farmer and you are I can say that suppose you are a farmer and you are using the same pesticide each and every day. Okay, to kill the insect or to kill the insect in your land. Okay. Now what will happen after using the few days? You obviously will see that if you notice that lots of insects are not killed because if we are using the same pesticide each and every day, so the insect will get some internal power to absorb those pesticide. So he immediately, the insect will get some immunity power. They will absorb that easily. So it will be best. Suppose today I am giving one pesticide, tomorrow I will give another pesticide. That means the taste will be different for that insect. The taste will be different, so the work will be effective. Give me you another example. Suppose if you always clean the same corner of your room, the rest is dirty. So you have to change your cleaning pattern, just like changing your taste. There are 4 corners in your room, and you are cleaning the one corner each and every day. Means the other 3 corners, there will be some dirty place will be there. So it will be best if you clean each and every corner, right? That means you have to changing your pattern. You have to changing your taste pattern. So pesticide paradox is called as like running the same test again and again won't find new bugs. There is 4 module in your application. Suppose 4 module in your application, and you are testing module 1 each and every day. Obviously you will not get many bugs, because the same module you are testing each and every day. So it will be best if you follow the 4 module, so you will get more bugs. So running the same test again and again won't find new bugs. You have to change your testing process. That is called as pesticide paradox. Okay. Now point number 6, testing is context dependent. Means, let me give you one example that testing is context dependent. Means, example, suppose you test a phone and a fridge differently. So you have one phone and you have one fridge. So what phone needs? Phone needs performance testing or battery checkup. Phone needs, let's say, performance testing and battery checkup. And what fridge needs? Fridge needs the cooling check and power check. That means same testing we are not applying for the both, right? So how you test depends on what you are testing. That is called testing is context dependent. If you are testing, suppose you are testing login process, so then you have to test only the login procedure. You cannot test there the forget your password procedure. So testing is context dependent. Whatever you are testing, you have to follow that particular process. There is 2 different processes are there. You cannot apply the same different process in 2 different things. Just I'm giving an example like that. Suppose you are testing a phone and a fridge differently. One needs performance test. Let's say phone needs performance test and battery checks, and the fridge needs cooling and power checks. That means same testing techniques don't apply to both. So you have to see that what is my requirement. That's why I'm saying that testing is context dependent. Means how you test, it depends on what you are testing. Okay, so testing approaches vary based on the type of application. In which application you are testing? It may be mobile application, it may be desktop application, it may be web application. So you have to vary. Your testing approach may vary based on the type of application, and is always depend on how you test. Is always depend on what you are testing. That is called as testing is context dependent. Okay, now point number 7, principle number 7, absence of error fallacy. What does it mean? It means, suppose you have installed one application in your phone. Just for example, you have installed one application in your phone, and you are using that application. You are trying to use the application, but you cannot use that because it's too hard. You are not getting all the points properly. Okay, it's too hard. Then what you will do? Immediately you will uninstall that application. Immediately you will uninstall the application. Suppose you have installed one game in your phone, and you trying to play that game, and you notice that sometime you are not able to play that game properly. So you are not able to play the game properly. It doesn't mean that the game is wrong. The game is hard. That's why you cannot play it properly. Then what you will do? Immediately you will uninstall it. That means absence of error fallacy. Even if there are no bugs, you are testing on application and there is no bug, the product can still be useless if it is doesn't do what user want. Okay, suppose your client or your customer has given one application or given some requirement to our company, and as a company we are developing that application. At the end we have deployed the application to a live environment, and when all the live user or end user they are using the application, they cannot use it because the application actually that is critical to understand that what is the business logic of that application. So maybe the end user will not use that application. So there is no bugs. That doesn't mean that everyone will use the application. So even if there is no bugs, the product can still be useless if it doesn't do what user want. Example, suppose a mobile app works perfectly, but it's too hard to use. A mobile app working perfectly fine, but it's too hard to use it. So people will still uninstall it. That is called as absence of error fallacy. There is no error, but still application will not be used by the user. That is called absence of error fallacy. So now you guys are very much clear about that 7 principle of software testing. Testing shows presence of defects. Exhaustive testing is impossible. Then early testing. Then defect clustering. Then pesticide paradox. Then testing is context dependent. And at the number 7, absence of error fallacy. So you guys are very much clear about this with the real-time example. If you guys remember the real-time example, then you can easily answer it. And that is a very, very, very important question. As a tester, obviously you have to follow this principle whenever you are going to test any application. So you have to make sure on that. Okay, I think you guys got that particular point, or the 7 principles of software testing. So if you guys have any doubt, please comment me and share these videos to your nearest friend. So see you in the next videos. Thank you.